Alright, moving on to section C, question 1b. Alright, question 1b largely is based on a kinetics topic. So in this question, 4 experiments are done using different volumes of reactants. Okay, so the first question, explain why varying volume of water were used in each experiment to keep total volume constant. Alright, so in this question, the question already indicates that total volume is kept constant, and the question demands a reason why. Okay, so this is to keep total volume constant, right? Because by adding different amount of water, so as to we can establish that volume of reactant used is directly proportional to the concentration of reactants. Alternatively, you guys can also give reactants in reaction mixture is proportional to volume of reactant used. Alright, so either in prose or in equation. Okay, so some students were thinking that is to allow the reactant concentration to be directly proportional to rate, right? But in this case, that defeats the whole purpose of the kinetics experiment, because in this case, if rate was to be directly proportional to the reactant concentration, all of them will be first order. Alright, so you have assumed that it's first order. Okay, so it's not appropriate. So the idea is that you want to, example, if I use 5 cm cube versus 10 cm cube, this would imply that the concentration of BrO3 minus has doubled. Okay, so by keeping total volume constant, then you can make such a comparison. Okay, if not, let's move on. So to determine the order of reaction with respect to each reactant, okay, so the choice of experiment is important. Okay, so in this case, let's take a look. We are choosing the BrO3 minus, I minus and H plus as the reactant. So for BrO3 minus, I will compare experiment 1 and 2. Why? Because in experiment 1 to 2, the BrO3 minus has doubled. The rest of I minus and H plus remains constant. Okay, to determine the order of reaction with respect to H plus. Alright, so in this case, I will compare between experiment 2 and 3. Why experiment 2 and 3 and not 1 and 3? Because your H plus concentration increased 3 times, whereas your I minus and your BrO3 minus remains the same. So in this case, for BrO3 minus and H plus, since the other factors are kept constant, only the one that we want to investigate changes. Alright, recommendation to use, therefore use the inspection method. For the case of I minus, if you look at I minus, I will definitely have to involve experiment 4, because experiment 4 is the only one that is different from experiment 1, 2 and 3 for the volume of I minus used. Then it really doesn't matter which experiment you compare, because no matter which experiment you compare, alright, it will involve another reactant changing its concentration. So for example, if we were to compare between experiment 1 and 4, I minus doubled, but BrO3 minus tripled. Alright, if I compare between experiment 4 and 2, I minus doubled too, H plus remains the same, but between 2 and 4, the concentration of BrO3 minus increased by 1.5 times. Okay, the one that I will avoid comparing is between 3 and 4, because 3 and 4 in this case, you can see every single reactant concentration changes, which makes analysis difficult. So as a result, for I minus, because there is no situation where all other factors are kept constant, the suggestion is to use the calculation method. Okay, because it's difficult to explain using the inspection method. Okay, so without further ado, let's take a look at how we present our working. So as I mentioned, for BrO3 minus, we look at experiment 1 and 2. So state the experiment that we compare, explicitly compare experiment 1 and 2, and go straight to the concentration. Alright, always relate any change in the concentration to the change in rate. This allows us to determine the order of reaction. Okay, so I say again, always relate change in concentration to change in rate. So in this case, comparing experiment 1 and 2, BrO3 minus doubles, or you can say increase 2 times. Rate also doubles, and as a result, the concentration change to the rate change is proportional. Double, double. And therefore, order of reaction with respect to BrO3 minus is therefore 1. Okay, so for the case of H+, we therefore, as I mentioned earlier on, we need to compare experiment 2 and 3. So, comparing between experiment 2 and 3, when H+ concentration triples, rate triples. So again, you can see that it is proportional. The change in the concentration is directly proportional to the change in rate. And as a result, the order of reaction with respect to H+, it's also 1. Okay, for the case of I-, as I mentioned, alright, because there's no two sets of experiment which only involve I- changing. So my suggestion to you guys will be to use the calculation method. Now, it was revealed from MYE exams that many of you are very weak in your calculation method approach. So I'm going to show recap on how we present our answers. So let rate be the rate equation. So in this case, I give a generic rate equation. But since we have determined the order of reaction with respect to BrO3 minus and H+, I can further simplify this to simply like BrO3 minus the power of 1, I minus Y. You can use any symbols if you want, and H plus 1. Again, that 1 is optional for you guys to put. So with that, I can compare between experiment 1 and 4 if I want to. As I mentioned, you can either 1 and 4 or 2 and 4. Okay, substitute in your values. Cancel away the common terms. Alright, so in this case, H plus is kept constant, so H plus cancel out. The rate constant K is cancelled out. 5 over 15, it's simply your 1/3. 25 over 50 is simply your half. So 1/3 over half the power Y is equals to rate 1 over rate 4. Rate 1 over rate 4 in this case is 1 over 6. So if you bring that 1/3 over, it's the same as 1/6 multiplied by 3, and therefore you get half Y equals to half. 1/6 multiplied by 3 is 3 over 6, and you therefore get half. So half the power Y equals to half, Y equals to 1. So therefore order of reaction with respect to I minus is also 1. Now, for those of you who want to use the inspection method, your explanation needs to be clear. So for example, if you were to compare between experiment 1 and 4, when I minus doubled and BrO3 minus tripled while keeping H plus constant, rate increases 6 times. So you need to state all the changes in the concentration, not just I minus, because in this case, there is, as I said, there's no set of experiment that changes only I minus. So once this is done, you cannot jump straight to say that, oh, therefore it's 1. Alright, we need to see a clear reasoning. Okay, so since reaction is first order with respect to BrO3 minus, when BrO3 minus triple, rate should triple. So as a result, BrO3 minus triple, rate increase 3 times, but we see increasing 6 times when I minus double. So as a result, when I minus double, the rate is observed to double. Double from 3 times to 6 times, and therefore it's therefore proportional, and therefore order of reaction with respect to I minus is 1. Now, the phrasing for this is a bit more complicated, so that's why I strongly suggest you guys to use the calculation method approach. The calculation method approach requires you guys to be very good with your indices manipulation. Again, these are O-level mathematics concepts. It's expected that you have no trouble with handling simple math like this. Alright? Many of you have issues with handling indices and make a lot of careless mistakes in your calculation. Alright, which is regrettable. Okay, so as I mentioned over here, strongly encourage that students use the calculation method to determine the order with respect to a reactant. Alright, when you're unable to get 2 experiments where the other reactants' concentration are kept constant. Now, I need to remind you, you need to state clearly the experiment numbers that are compared and the reactants that are being varied clearly. In this MYE exams, we have given you benefit of the doubt, but moving forward, this will result in credit loss if I cannot follow any of your reasoning. Alright, so Just take note, in this case, we have given you the benefit of doubt, but moving forward from here, we will not. Okay, let's move on to C. Okay, in C, if you read the question, at significantly low pH, which means it's a different condition, the rate equation is different. And the rate equation is given as this. So you're given the concentration of BrO3 minus, I minus, and H plus, and you're given initial rate. So substitute in your rate into this, substitute in your concentration into the reaction, the equation. You should be able to find your rate constant. Alright, it's very, very sad that many of you cannot read the question carefully. It's a H plus to the power of 2. Alright, so you need to substitute in your values correctly, key in your calculator correctly. Alright, and you should get 32.1, not 16.0. Those of you who got 16.0 is because you forgot to square your H plus concentration. Now, with the units manipulation, again, many struggled despite it being a simple indices question. Your rate units is mole per dm cube per second, that's your rate. Since the overall order is 1, 1, and 2, order of reaction with respect to each reaction is 1, 1, and 2, overall order is therefore equals to 1 plus 1 plus 1 equals to 1 plus 1 plus 2 equals to 4, and therefore it's mole per dm cube to the power of 4. That's a concentration term, concentration units to the power of 4. So with that, when you substitute in your values, when you substitute in your units, you can cancel in mole per dm cube over here, you left with this, and as a result, take a look. This is 1 over mole per dm cube to the power of 3. So as a result, the unit should be mole. So you can see here, I have per second over here as a numerator. Mole 3 dm minus 9. 3 times 3, not 3 plus 3. Alright? And as a result, your units will be mole negative 3 dm 9 per second. Again, all of this has little relevance to the chemistry concept. These are all your indices that are supposed to have been taught to you guys during O-level mathematics. Alright? Okay, with that, we are done with B and C. Next video, we will discuss the last part where it involves the titration concept.